Have you ever wished you could just hit copy and paste on a real-world object? Take a car part, a building, even a priceless sculpture, and just zap a perfect digital version of it onto your computer? Well, guess what? It's not science fiction anymore. Today, we're diving into the incredible tech that makes it all possible: 3D scanning. And, for the longest time, this whole idea felt like something straight out of a movie. But as this quote nails, the future is officially here. 3D scanning isn't some far-off concept anymore. It's a real, powerful tool that's completely changing how we design, build, and even preserve our world. This image right here, this is the whole magic trick in one picture. You start with something real, like this complex skier. A scanner captures every single tiny detail, turning it into a digital blueprint. And then, a 3D printer can bring that blueprint back into the physical world, creating a perfect copy. It's this amazing, seamless journey from physical to digital and right back again. So here's our roadmap. First, we'll break down how this stuff actually sees the world. Then, we'll look at the different tools in the modern scanner's toolkit. After that, we'll get into why digitizing our world is such a big deal. And finally, we'll take a peek at what the future has in store. Let's jump in. All right, first up, how does a scanner actually work? How does it look at a solid object and turn it into data? Let's get into the fundamentals of how it sees and understands the world around it. So the secret sauce, the fundamental thing that all 3D scanners create, is something called a point cloud. I want you to imagine a 3D photograph, but instead of being made of pixels, it's made of millions and millions of tiny little dots. Each one of those dots has a super precise address, an X, Y, and Z coordinate in 3D space. It's like a perfect digital skeleton of the object. Okay, so how do you build one of these point clouds? Well, the scanner is basically shooting out these incredibly fast pulses of laser light. Every single time that light hits a surface, the scanner records its exact position in space. And it does this millions of times a second, just relentlessly mapping everything it can see until it's built this massive, dense cloud of data points. Now, this is the really clever part, how it actually measures the distance to all those points with such mind-blowing accuracy. There are two main ways it does this. On the left, you've got time of flight. It's just what it sounds like. The scanner sends out a pulse of laser light and literally times, with a stopwatch, how long it takes for that light to bounce back. Simple, right? On the right is phase shift. This one's a bit more advanced. It compares the shape of the light wave going out to the one coming back. Both methods are just incredibly effective at figuring out exactly where millions of points are in space. So now that we know how scanners see, let's look at the tools themselves. Because this isn't a one-size-fits-all situation. Not at all. There's a whole toolkit of different devices out there, each one designed for a specific job, from scanning a tiny screw to a massive skyscraper. This chart gives us a fantastic breakdown. You've got your handheld scanners, which are super portable and easy to use, but the accuracy and cost can be all over the place. Then there are arm-mounted scanners, less portable for sure, but they are incredibly precise, which is why you see them in factories. And then you have the big guns, terrestrial scanners. These are insanely accurate over huge areas, but yeah, they come with a hefty price tag. It's always this trade-off, right, between portability, precision, and price. And here's a perfect example of that first category. This is a handheld scanner, and it's totally self-contained. It even has its own screen. This thing gives you complete freedom. You can just walk around an object, capture it from every angle. It's all about being flexible and fast. But what if you need absolutely perfect, razor-sharp precision? Well, that's when you bring in an arm-mounted scanner like this one. Here, it's capturing every single curve and weld on a motorcycle frame. This level of accuracy is exactly why it's the go-to tool in manufacturing for things like quality control or, in this case, reverse engineering. And finally, we've got the heavy hitters, these tripod-mounted terrestrial scanners. These are the workhorses for architects and construction crews. You just set one up on a job site, hit a button, and it spins 360 degrees, capturing millions of data points to create a perfect digital twin of a huge space. It's amazing. Okay, so we've seen the tech and we've seen the tools, but let's get to the big question. So what? Why is this so important? Let's dig into the real-world impact and figure out why digitizing our physical world actually matters so much. Look at this list. The applications are practically endless. For manufacturing, it's a game changer for quality control. In architecture, you can create these living digital models of buildings. Hollywood uses it for jaw-dropping special effects. It's literally changing lives in medicine with custom-fit prosthetics. It's helping us preserve our critical infrastructure, and, as we're about to see, it's incredible for reverse engineering. Here is a fantastic, real-world example of reverse engineering. This technician is scanning a boat hull to capture its exact shape. Now, why would you do that? Well, maybe the original blueprints were lost to time, or maybe you want to analyze the existing design to make it even better. And once you have that digital data, what can you do? Oh, the possibilities. You can create replacement parts that fit perfectly the first time. You can run virtual simulations to see how the boat performs in the water without ever getting it wet. Or you can just create a permanent, perfect digital record of the boat exactly as it was built. Now let's switch gears to a field where this level of precision isn't just helpful, it's literally life-changing. We're talking about medicine. What you're seeing here is a prosthetic knee joint being scanned with incredible care. Because in medicine, accuracy isn't just about quality, it directly impacts a patient's health and mobility. And this is where it gets truly amazing. Think about this workflow. An MRI scan of a patient can be converted into a point cloud. That point cloud can then be used to 3D print a medical implant, like a knee joint that is custom fit to that one specific person. This is the definition of personalized medicine, and it's happening right now. So the things we can do today are already blowing my mind, but this technology is moving at lightning speed. So let's look ahead. Let's peek over the horizon and ask, what's next? Because the future is definitely scanned. We're seeing some really exciting trends emerge. Of course, scanners are getting smaller, faster, and more accurate. That's a given. But the really big shifts? Automation. Scanning is becoming a built-in part of the production line. And that leads to the digital twin. This isn't just a static 3D model. It's a living, breathing, interactive digital copy of a real factory or a machine that's updated in real time. Imagine being able to test a new process virtually before spending a dime. And it all comes together with augmented reality, or AR, which will let us actually see this digital data overlaid on the real world through glasses or a tablet. This right here, this is the future of automation in action. This machine is called the Zero Touch, and it's for industrial quality control. A brand new part comes off the assembly line, you place it inside, and it's scanned automatically. This is what the industry calls in-process metrology, which is really just a fancy way of saying you're measuring the part right there on the production line, instantly. And why is that such a game changer? Speed and efficiency. Instead of pulling a part off the line, taking it to a lab and inspecting it later, these automated systems give you instant results. If a tiny defect is found, the manufacturing process can be corrected on the spot. It saves time, it slashes waste, and it drives quality way, way up. So, as this technology keeps getting better and better, as we get closer to creating this incredibly detailed digital twin of our entire world, it leaves us with one thrilling question to think about. What will we build? What will we preserve? And who will we heal next? The possibilities truly are endless.